Yo, what's up everyone? So here's our first lesson for week 2, and I'm pretty sure I'm going to send it in on time, so I'm pretty happy about that. It's currently 1 a.m. Sunday night, but I'm kind of a late worker sometimes, and I was grading your problem sets, and the thing that made me really happy is most of you have turned it in. So tomorrow I'll make sure to send out messages if you haven't, or if I didn't find it, but most students are turning it in, which is good. Um, so what you notice is that I have this kind of weird thing up, and it's a textbook, and the reason is I still haven't figured out how to print. And today I decided I was going to buy a printer, so it's quick story time. And it turns out that like all the printers, I went to Best Buy, and there's a specific printer I wanted, and but I went to Best Buy and all their printers were sold out. So I'm buying a printer, but it's only going to get in here Thursday. So until then, I'm just going to work on paper. But I wanted to actually show a graph because the questions show a graph. So I found a textbook I have, and I just found like a little 5x5. So I'm pretty proud of that, honestly. I think that was a savvy move of me. But once we have printed worksheets, which will come for week 3, I'm going to be pretty stoked. So let's just tackle the question. I don't think it's going to be too hard. But we're still talking about linear equations, and we're trying to figure out all this stuff related to lines. And if you haven't realized yet, graphing is going to be a huge part of this year. So even though this is probably a review for a lot of you, it's good because the things we're looking at now are going to build. So we have this graph, and what it asks us first is, what is the y-intercept of the line? So if I'm looking at this line, we started the year by graphing these, meaning that we know that if the y-intercept is wherever we intersect this line, and if we have an equation like y equals 2x plus 3, that tells us we have to start at the number 3, but we could work backwards here too. So if we're given the line, we don't have the equation yet, and we're basically trying to figure out the equation for this line. But usually we can notice what the y-intercept is. Sometimes it's in between 2 points, and then we'd want to use algebra. But here, all we have to do is identify that the y-intercept is at 4. So for A, all it says what's the y-intercept, and we're going to say y equals 4. But what's even better is to write the point. Okay, so 0, 4. And that's one of the points on our line. For B, and this is the big part of the lesson, and I'm going to teach a lot and then we'll get back to B, but it says identify 2 points on the graph, and we want to use them to find the slope of the line. So really the goal today is to be able to look at a line and figure out what its slope is. My nails are really long, forgive me. Yeah, my nails are long. I feel self-conscious, but whatever. Okay, so the goal is, if we have a line, we want to figure out how can we figure out the slope from the line. Before, and yesterday or last week, we would put the slope into an equation, but now we want to work the other way. And what we know is that the slope basically tells us our rate of change or how steep our line is. So a line is always changing at the same rate, right? It's always going down the same. If it wasn't, it would do kind of something like that, right? It's going down more, it's going down less, etc. But the line is always going down at the same rate. And the way that we would graph a line is, we know that as we move over 1, however much y changes, so x is moving 1, however much y changes is going to give us the slope. So here, we moved over 1, and then we went down 2. So the slope here is going to be -2. Okay, that's the big idea. And now we kind of want to derive a formula if we're doing this all by hand. So sometimes it asks you to find the slope, and you don't have the graph, but we also want to understand exactly what's happening here. So what I want you to think is slope is a ratio. the slope here is -2 because it's -2 divided by 1. And what was really happening, and I'm kind of excited, this is the first big thing I'm teaching that I enjoy, and I'm a nerd for math. But here, we knew that as we moved over 1, as x changed 1, y changed -2. Y went down -2 to get to the next point, from this point to this point. So the bottom was just telling us the change in x. And this triangle, you've probably seen it before, can explain change, or it means change. So basically we changed x. So basically we changed x 1, the change in x was 1, and the change in y was -2. Okay? So slope is just the ratio between how much y is changing compared to x. Okay. So the question that this asked was pick 2 points and find the slope between them. So we don't have to necessarily move over 1. Okay? All we have to do is figure out the ratio of x and then also the ratio of y. So let's choose 2 other points. We'll choose this point and this point. And if I want to find the slope is going to still be -2 because it's the same line. But if I wanted to find the slope between any 2 points, this point's 2, 0, and this point is 5, -6. All I have to do is figure out how much x is changing and how much y is changing. So if I move over, we see that we're going from 2 to 5. X is changing 3. And y is going from 0 to -6. So y is going down 6. So the slope is going to be the change in y, so -6, divided by the change in x. So -6 divided by 3 equals -2. And this was all a roundabout way, and this is the last part of this for B. But if I ever want to find the slope, all we did, and this is my favorite part, is if I want to ever find the distance between 2 points, I just take one point minus the other. So if I want to find this point, we'll call this point 1 and this point 2, the slope between those 2 points, the bottom, that 3, was just 5 minus 2, okay? And the top was just -6 minus 0, right? That's how we got -6. So 5 minus 2 gave me 3, and -6 minus 0 gave me -6. So even without the math, if I give you 2 points, you can find the slope using the slope formula. Okay, so that's all from the graph. For B, I'm just going to write the notes out, but we'll proceed from there. Okay? Okay, so again, if a question ever asks you to find the slope using 2 points, this is kind of the technique for that. From there, for C, it's going to actually be pretty easy for us. It just says to create the equation. So with all of that, we found the y-intercept as 4, and we found the slope as -2. So that's just like last week. Where we can put this in y equals mx plus b if we have those 2 points. And I may have given you this exact equation before, and if so, I'm sorry. I just kind of chose an equation quickly that would work for this graph. So that's that. But if you ever were asked to find the equation just from a graph, the steps are the same. Find the y-intercept and find the slope. D is the last part, which I think is going to be pretty interesting of this question. And it just is asking us to write an equation in the other form. And the other form, remember, is y1 like this, and all you have to do is plug in the slope and plug in a point. So I wanted to show this as just a way that we could derive it again, but if you ever were asked to use this, you can choose literally any point, and you would get a different answer, and they're all valid. So you could plug in this, and it would work, or you could plug in this. So if I were to plug in this, for example, the y value is -6, so minus a negative becomes positive. The slope is -2. And the x value was 5. So that would be valid. But if you wanted to plug in this instead, the y value was 0, so it becomes y equals -2, x minus 2. Okay? So that would be how you could put it in that form. And we do know that it's the same equation, so let's do this very quickly. This and this are equivalent. So if you were asked to convert this back, we did this the other day, but we can review quickly. You'd want to undistribute and then bring the 6 over. -2 times 5, sorry, -2 times x, and -2 times -5. And we get the same thing. Okay, so that's D. That was the longest example. And then we're going to go over 2 other examples that are kind of doing the same stuff. Okay, so for 2 and 3, we don't even need the textbook anymore because we're doing it all by hand. And it's asking us to basically figure out equations and slopes just using points and not an actual graph. So we learned the skills, but now we won't do it with a visual. So here it says we're given 2 points and we're asked to find the equation of that graph. And just remember that these are 2 points that we could graph this. So 9 to 17 is going up, but we don't need to graph it to figure out what equation would make that straight line that goes between those points. So think that our standard form is y equals mx plus b. And if we want to find this, we just have to find the slope first, and then we'll talk about how to find b. So if we're going to use our slope formula, all we ever need is 2 points, and we're just going to plug these in. So think of this as point 1, and this is point 2. Sometimes that helps students. So y2 is, this is x and y. So 1 minus -3, and 17 minus 9. So this one always before this one. And then I always put it in parentheses because it's always minus, and if it's a negative, that's going to become positive. So the top here becomes 4 because it's 1 minus -3, and maybe you've learned the trick before, but you can kind of just combine them to make a big positive sign. It kind of looks like a positive sign a little bit. So just, that's like a small trick I use. And then it would be 4 divided by 8. And that works. 4 divided by 8 works. But remember that if you have a fraction, simplify if you can. So the slope here is 1/2. And fractions are totally fair game. So we have one part of this, and then we're stuck with the second part. And to teach this, I'm going to show us both methods. The first, and some of you may have already thought to do this, which is good, and this does work, is we already have enough information for the slope point form. If we plug in this for 1/2, we can put either of these 2 points in for the y1 and x1, and then we can convert this to y equals mx plus b. Okay, so let's actually do that. I avoid negatives if I can, so I'm going to plug this into my equation. So again, our goal is just to make an equation in y equals mx plus b. And once we find the slope, there's 2 ways we can go about it, but one way is just use the point slope form. So y was 17 and x was 1. And then all we would have to do is undistribute and add this over, and it's going to give us the equation. And I always prefer to keep things as improper fractions. So this is going to be 16 and a half, but it would probably be better to write it as a fraction. So think this one through, because I believe in you to understand this, but that's the same thing as 34 over 2, and we're taking one of them away from it. So 33 over 2. And just think 32 divided by 2 is 16, and then there's a half left. So we've succeeded with this whole question, example 2. That's one way to do it. But if you wanted to, a second method is you can plug in that point into this equation, and the same thing's going to happen. So there's no need to use this form if you can be savvy enough to just think this equation has to work for every point. So if I plug in x, oh, I messed this up. Okay, so I did that wrong because I mixed up the x and the y. So this is what it actually should look like, but I didn't care to change the explanation because I thought the explanation was fine, but maybe you noticed that, so this is correct. But now we can go back to this and find the same equation by just plugging into this. So if x is 17 and 1 is y, we can plug in and solve for b. All you ever need to solve an equation is one variable left. So here, we can figure out what this number is by just isolating b. So first, 1/2 times 17 is 17 over 2. And if I move this over here, b is going to be by itself. So like that. And therefore, if I put this into the equation, we're going to get the same thing that we got here. Okay, so that's that. And here's what I've decided for the rest of this. That's all I'm going to teach. The video will be not too bad. But there's some example problems that there's going to be some practice problems that look a little different, but are the same concepts, okay? So example problem 2 went through the hardest it could get, but if you ever get lost while doing a practice problem, really recommend looking at the answer key to see how I do it, okay? I give you the answer keys so that you can kind of work through correct notes, and when I used to take math classes, like I would look at notes and answer keys quite a bit. So don't copy off of them, but if you ever get lost, make sure to look at that. So yeah, we made it. Good work today.